Hello, Mr. Oprisan, and welcome to Computer Science Chats. How are you?
Good. How are you?
I'm good, thank you. I have several questions to ask you. So first, could you please introduce yourself and your educational background?
Sure. So my name is Andrei Oprisan. I'm currently the CTO of OneScreen.ai, SaaS ad tech marketplace company. And my educational background, I'm an engineer through and through computer science, undergrad at NYU, and then master's at Columbia University in computer science as well, with a focus in machine learning.
Thank you. So what is it that inspired you to pursue computing as a career?
Yeah, so for me, it was really all about being able to build things. So I love tinkering with things. I love, taking things apart, putting them together, figuring out how they work, and computing in general, just gave a real avenue to be able to build things from scratch, modify existing things, and really, you can build anything online or in these virtual sort of universes, or out in the real world with technology. And so that's what really attracted me to it, that ability to build things, and have computers basically do what you instruct them to, which is kind of fascinating.
That's very interesting. How would you describe computer science or computing fields in general?
Yeah, I think computer science or computing fields give you the framework to be able to think in a very structured way, right? In a way where you can decompose a problem into building blocks that you can then optimize in different kinds of ways. And that's really applicable to a lot of other fields, from finance to marketing to sales to all sorts of different areas. So really interesting, and sometimes too complicated way of maybe looking at things, but certainly provides a good framework to really be able to analyze, to be able to optimize, to be able to then automate certain tasks and certain give answers, good answers, data driven answers to problems. And to me, that's what really it fascinates me about the field, and why I continue to want to study and be part of it, even now, decades after sort of the initial education.
Thank you. Could you describe some of the activities that you do through your work?
Sure. So a lot of what I do as an executive is really more focused around how do we as a company make money, right? How do we make sure that we're giving customers what they want, with products, with services, with capabilities that someone is willing to pay for, making their lives easier, better, faster, cheaper in some fashion, right? Creating some value for them, whatever that means to them, and then making sure that from a broader strategic roadmap standpoint, what are we trying to do and why, we can then execute on that. So we come up with something they want to build. Why is that? There's reasons, there's analysis, and then how do we make sure that we have product and engineering teams that can actually build those things, that can actually say, if the customer wants a website with a button on it, can we build that? If so, right, what do we need? Who do we need? And with what kind of skills to be able to do that? Obviously, I'm oversimplifying to prove a point, but a lot of these lower building blocks, there's different kinds of skills, different kinds of technologies, all sorts of different choices that we can make. How do we make sure we build the organization that can effectively enable that? And that's part of what I do is from a business standpoint, translate those business needs into something that we can then solve with technology. And from a technology standpoint, can we make sure that we're actually building the right technology? Do we have the right people in place, the right teams, the right skills in place to be able to execute on that roadmap, that vision, and really bridging the gap between the technical folks and the non-technical folks to to guide us in the right direction.
Thank you. What do you like most, and what do you find most challenging about these activities?
Yeah, I mean, I think it's always has to be a balance between how do you make sure that you're investing in technology at the right amount and doing things the right way, in the more technical way. We're solving interesting problems from an engineering standpoint versus we're just trying to make money, right? And at the end of the day, we're a business. We have to move fast. And to what extent do you trade off speed for quality? Just like if you were to build a building, you don't want to, you should follow certain code standard and make sure you're following certain engineering principles and building that building. Otherwise, you may have a foundation that crumbles. Same thing from a technology standpoint. Sometimes, and too many times, companies find themselves, making the wrong trade-offs between speed and quality in terms of building technology that can serve some type of function. And so again, that I think I would say that's always the most challenging aspect, is striving the right balance between the two, paying off technical debt, just enough technical debt so that we can keep getting faster and better, while not only focusing on that. We still have to move, what the customer wants and the company needs us to develop, to do that faster. It doesn't matter generally just how good your product is if no one can see it, and if no one doesn't solve any pain point that they may have, right? And so it's a delicate balance, right? And it's part of you have to be pragmatic. You have to follow certain principles, and then you have to balance it out with how do we make sure, again, we make money, we can pay people their salaries, and give them the appropriate raises and things like that over the long term, which means probably need to make more money, right? And so it's always a delicate balance between the ideals and the realities of running a business and doing something for customers.
Yeah. What advice would you have for high school students who would like to get into your field?
Yeah, what I would recommend for younger folks, who want to get into computing, computer science, or really any engineering field, is try to make small steps in terms of getting into the field and trying different things. It can be as simple as trying to customize a game, right? Or trying to build your own, I don't know, Minecraft levels or things like that. And over time, asking yourself, well, how can you do more? How can you customize things more? How can you understand how it actually works behind the scenes? How does that game experience, let's say, get rendered, right? Or how might you build your own game that could act the same way, right? Big questions. Takes some research, takes some tinkering, takes some taking things apart, and many times failing. But I think that's a critical part of learning, and probably some of the most rewarding experiences have been when I really tinker with something myself and try to learn a new topic or try to figure out how something really works. And it took me many tries, many failures, but when you finally get it, it really sticks with you more than just being handed an answer, right? Like anything else in life. And so it's part of that exploration, part of that analysis, and really trying to figure out, okay, even if you now know how something was built or how it works, how would you make it better? How would you make it a little bit faster, a little bit more customizable, a little bit more maintainable, right? Something that might be interesting to you, whatever that might be, and trying to find an answer to that, and then testing it out, see if it really if that is the right answer, and how would you even test that out, right? Really using the scientific method and really being able to analyze things. And that's what I would recommend. Start with something or with a topic that might be interesting to you, or give you something you're passionate about, and then figuring out how to apply technology to that, figure out how to apply yourself to answering that kind of question in that context, and then exploring from there, right? There's technology all around us, more and more and more, right? Every single day. I'm sure there's a way to start. But again, some of this can be daunting, right? So like, where do you even start, and how do you even do that? And I would say, don't be afraid of failure. Failure breeds resiliency, breeds curiosity, right? And the more curious you are about something, the more likely you are to eventually find the answer, right? And many of us, the last piece of advice that I would give is, many of us, still in, had all sorts of roles, leadership roles. I've been an engineer, hands-on, all the way to, to your manager, director, VP, CTO, all the way up, right? There's not nowhere else to really go. And everybody, to some extent, is faking it. Everybody, to some extent, is still trying to figure it out, still learning, but they're doing that, right, with more experience, with a little bit more confidence. But again, no one has all the answers figured out. Nobody does, right? And so don't be afraid to try something. You'd be surprised, just how far you can get by, staying curious, staying humble, wanting to learn, and then doing your best to answer those questions. And again, many of us are still figuring things out, because technology keeps changing so much. It was true 20 years ago when I was when I was entering college, is very different than what it is today, right? And how to build applications and websites. The technology has completely changed, and will completely change, every so often. There's better ways, faster ways, more architecturally sound ways to build, or to answer those exact same questions and build the solutions. And I think, having that curiosity is critical to really being able to, do something better, cheaper, faster, ultimately for customers. Because at the end of the day, we're building technology for a reason, whether it's for yourself, right? Maybe you're the customer in that case. You're trying to solve some kind of pain point or problem or curiosity that you have. Or if you're part of a big company or a smaller company, where you're building something, some website, some app, something, that you're hoping someone will actually use, right? You're always building something for someone. And that curiosity about the technology, who the customer is, what the problem space is, that is absolutely critical to being successful, in my opinion, in computing fields.
Yeah, that's very interesting. Where do you think that computing is going to go in the future?
I think, more and more it'll hopefully make our lives easier in some fashions, right? I think there's going to be more technology in everything that we do, from driving your car, which is a pretty obvious extension, to how you do your work on a daily basis. More apps, more tools that you can use, compared to years ago, where search engines weren't, they were just starting off, right? And so even finding information was hard. Now you have chatbots and all sorts of Alexa sort of home automation systems and other things that can do a lot of things for you. So I think more and more we're going to see technology enabling human experiences, whatever those might be, driving, walking, running, whatever, the travel, etc., to down to doing your job on a daily basis. And I think it's even more important, so that as we're building this technology, as people working in these computing fields, to really keep in mind who the customer is, right? And be able to put yourself in their shoes and help them have the right solution, with the right level of empathy, with the right level of ease of use, but also thinking about the consequences of how we build this technology, right? And so I think there's probably not enough of a focus on the ethics of how we continue to evolve technology, especially with things like machine learning and all sorts of algorithms that can make decisions increasingly for you, or make the recommendations, where the recommendations are only as good as the data that we give it to train it. A very simple example of there's the classic machine learning homework problem, almost, of building a classifier of hot dog or dog sort of identification. And so you can feed it different data, and your algorithm is only going to be as good as that training data, and of course as your algorithm, actual underlying algorithm is. But that data can truly skew the answers, can truly skew the recommendation of someone maybe getting a second look to get a job or not, based on keywords, based on educational experience and life experience and things like that. So I think we need to, and these things have real impact on people's lives. So I think we need to really think about how we're designing these systems so that they can have a positive impact, not a negative one, on people's lives.
Yeah, thank you very much for meeting with me and for being willing
Sure.
to do this interview.
Absolutely, you got it.
Thank
Happy
you.
to be here. Thank you.